Okay, good afternoon, everyone. Today we talk about the new topic, which is clustering. So, do you guys ever had clustering before in your previous classes like programming? So pretty much you should know what it's about. So let me just briefly go over clustering concept. So just as a brief, in clustering, you don't have a dependent variable. You have several observations that have some characteristics. The characteristics comes from the columns of your table or the variables, and you try to categorize your observations based on their similarity. Okay, having said that, let's look at this sample visualization, which I have two variables of x1 and x2. So looking at this sample data set, do you think how many clusters do I have? 3. Why?
So clustering is basically grouping data according to similarities. And in this, the different data points that are closer together would be in a single cluster. And just visually, it looks like there are 3 different kinds of data. So 3 different.
Yes, it's correct. So actually, theoretically, you can have as much of clusters you want. So here is, for human eyes, it's easy to distinguish 3 very distinct groups of observations. But even you can have 2 clusters. You can consider this one as 1 cluster, and this one as other cluster. You can. So what about even more? Maybe this is 1 cluster. That is another cluster. This is another one. This is another one. This is another one. So 5 clusters. So do you guys know how to find the best or the most efficient number of clusters? One of them is silhouette coefficient. So silhouette coefficient, it takes care of distance of centroids. For example, here, let's say I have this centroid, and this is my distance. Maybe here the centroid is here, and I have 2 distances. Maybe here, this is the one. So you look over the overall distance of your centroids from the closest observations in their clusters. So looking at the silhouette coefficient, you can have some experiment and just find what is the best amount of observations giving an objective measure. So silhouette coefficient is between -1 to 1. I'm not sure if you guys can see. So if it's close to 1, it means you relatively have a good number of clusters. If it's close to -1, it seems that some of the observations is better to assign to other clusters. And 0 is kind of neutral. It just means some of the observations could be on the borderline. It's not the only objective measure. There's some measures that with considering them, you can just find the best amount of clusters that you might need to create. Sometimes it needs some background knowledge. So maybe somebody from background knowledge from that domain would tell you historically, we want to look for this amount of clusters and it works best for us. Those are like subjective measures, but silhouette coefficient is objective measure, which works well. Also, additive look at the observation, and for her, for her eyes, finding 3 clusters here was very easy. I'm pretty sure it's the same for you guys. What if I have 3 of them, 3 dimensions or 3 variables? So we go over 3 dimensions. What about 4 variables, 5, 6, more? Sometimes we have 20 variables. So visual observations sometimes is impossible. So we rather to use more objective measures, which silhouette coefficient again is one of many. Okay, so having said that, so if you need to do clustering your project, maybe you should tell me that you had some try and error for finding the best amount of observations, sorry, best number of centroids or groups or categories, and that should be fine. But I don't want you guys just do one cluster and say that's it. So I want you guys to do some investigations. So for today's class, we have experiment for clustering. So again, same as before, please go on your model. The last week is week 9 here. Download the CSV file and Jupyter Notebook. Go to Databricks platform, create a cluster, and then upload both of Jupyter Notebook and also CSV file. And I give you about 5 minutes to do all of them. So then you should have such a page, and then whenever all of you get to this point, I start from here. Okay, so for today, we are working with one of the sample UCI repositories. And I mean, this sample is about agriculture. We are looking at some observations of wheat samples. So you already know there's two types of wheat in our samples, and we have like 7 characteristics from them. So area, parameter, compactness, length of kernel, width of kernel, asymmetric coefficient, and length of kernel groove. So using these 7 categories, we want to do clustering and just categorize our wheat samples into different categories. So you might say, what's the point of that? We already know we have 3 categories, but these 3 categories are, let's say, they're from different farms, or and they have different samples. But maybe if we look at the characteristics, they're pretty much similar. Or maybe you need to differentiate more. Maybe instead of 3 clusters, maybe you need to have 5 types of wheats. And if, let's say, if you think maybe 2 clusters is enough, maybe you can merge Karma and Rose together, or Canadian. Or if you want to make several categories, maybe you do like Karma, Rosa, Canadian 1, Canadian 2, Canadian 3. So anyway, so we have a sample of wheat grains, and they had some scanning equipment, and with those scanning equipment, they could find these 7 characteristics from the wheat data. By the way, if you, as I said, you can change your topic by third delivery. So if you still have difficulties in your data set, UCI has a really good sample of data sets. The good thing, whenever you go to, you check one of the samples. Oh my God, sorry, I should go back. So give a good description about the data, where did it come from, and maybe someone already used this data for different research. You even can look at their papers and get some idea what other people did with this data. So this is actually a really good data set that I strongly recommend for you guys, especially if you still suffer from finding good data source. Okay, any questions so far? So again, we import a Spark session, a Spark SQL session, because we want to do some data preparation or data management using SQL package, but you don't have to. So using SQL is not a necessity, but I just bring the SQL package, so in case you can see, you can do something with that. And I make a app name with the name of clustering. If you might forget here, because we are using just a free sample of Hadoop ecosystem, so it's just 1 cluster and 1 job per submission. So you don't have to have app names, but this is a good practice. So in the industrial level, you make several apps and you submit to a cluster and you wait for your results. With the app name, you can see the progress of your work. Sometimes if it doesn't go through, maybe we can just cancel. So having app names is a good practice, but again, it's not necessary. So I'm importing data set CSV file, and I'm just saying it has header. For infer schema, I said true. So what does it mean? Do you guys remember what does infer schema equals true means? Yes, it just means we let the Spark to just use its guess on the column type. So some column could be numbers, some could be like categories or classes. Using describe method, we can get some descriptive statistics over our data. So like arrow, parameter, compactness, length of kernel, width of kernel, asymmetric coefficient, length of group. All of them are numerics. And when I look at them, I don't see any empty cell. All of them have 210 observations. Mean standard deviation, for me, all of them looks good. I don't have the background in agriculture, but when I look at mean and variance, doesn't seem to be too bad. Seems to be, looks normal. I don't see any outliers. So in case you see a huge gap between mean and max, maybe you can do some experiment, you use some other packages to see if there's outliers. If maybe you drop those outliers, or maybe you do imputation if it's needed in case you have empty cells. But here seems to be good. It's the only way that I can do. I don't have any background knowledge. Maybe someone in agriculture would tell me it seems all of the data on the compactness may not looks crazy. Maybe we should drop that value. But here, with my current knowledge and descriptive statistics, it seems all of the data, all of the variables are fine. So we go from here. And for today, I don't use pipeline, but you might remember in the previous two sessions, I used pipelines. I mean, it's not a necessity, it's just a good practice, especially for big data and any large size projects. Having pipelines help you to just change some parts and just get the result quickly, especially if you need to have several experiments. Here, I just do it in the easiest way that I can. So I'm importing vector and vector assembler. Again, let me recall it. So in machine learning algorithms of PySpark, you need to have a feature and tell them what is your features. So the way that you define the features is just using vector and vector assembler. There is no mathematics behind of that. It's just the way you should let PySpark knows what are your independent variables. So you define them with a feature label. And how you create that label, you use vector assembler. Okay, so I give you a little bit of time if you have a question or you want to add some comment on your blocks. Then I go to the next one. Yeah. Okay, sure. So one of the good practices that you can do for your data preparation using, normalizing your data. Basically, you convert your numerical data to its standard normal equivalent. So if I recall it, x minus mean divided by a standard deviation. So you find a standard deviation of your variable mean, and x minus mean divided by standard deviation, it gives you the normalized value of your observation. So should you do it all the time? No, it's not necessary. But sometimes you are not happy with the result of your prediction. So maybe you normalize your observation to see if it helps or not. Especially if there is a high variance between your observation, normalization helps. So, and you might remember for your final project, I said find 2 different approaches and show me that you could you try to improve your prediction. One way you can have you can normalize your data and just show me if there is improvement or not. With center scale, I do it here. So from PySpark ML feature, I'm importing a standard scaler. I'm just saying that, okay, use the standard scaler. Input column is the features that I defined previously with vector assembler. And output is the scale features. I'm using both a standard deviation, but here I don't use mean. But if you want to also use mean, you can just make it true. Again, in machine learning, we just do by try and error. Sometimes when you standardize it, it's better to use mean, sometimes standard deviation, but we cannot prove it, which one is better, or if using both is fine or not. And I fit the scaler on my data and transform my data. So the new data set, which standardize it is, or scale it, is sit data scale. So basically, this data is just a scaled version of my data set. And as you see here, I just divided with a standard deviation. So later on, if you are not happy with the silhouette result, maybe you can come back and change it to true to see what happens. Or maybe you can exclude this one. Maybe you don't have to scale it. So you just do try and error to see if there's some improvement. Anyway, here, I'm using k-means. This is one of the basic clustering algorithm. I'm just saying that use scaled features and using 4 centers. And then I fit over my scaled data. So you might ask me why I use 4 clusters. I just want to see if it's better to increase number of clusters from 3 types of weights to 4 or not. Then I would look at silhouette coefficient to see how is it. So for evaluating my clustering, I need to import clustering evaluator. From clustering evaluator, I can find its silhouette coefficient. So as you see from a Spark ML evaluation, I'm importing clustering evaluator. I'm transferring my data, and silhouette value is just cluster evaluator, and I'm using evaluate method over my prediction. And finally, I'm just printing my silhouette coefficient. So if you run with 4 clusters, so the silhouette coefficient is 0.51. So it's more than 0. It's not negative. Seems to be okay. But let me just change it to 3 clusters. So it increased. Maybe 3 clusters, it seems to be a better number of clusters. So let's just change it to 2. is even better. Maybe instead of having 3 types of weight, maybe 2 of them are very close to each other. Maybe you can just make new clustering with just 2 groups of weights. Maybe over time, some of them just get closer to each other because of the weather conditions. So right now, based on what you see here, maybe 2 clusters are better.
I tried to get k is equal to 1 cluster,
but
then it gave invalid that because obviously you can't just have like 1.
It's not. It doesn't make that much of sense. One is everyone's there, so yeah. But it's a good practice. I really appreciate it. You try different numbers, and this is a good one. Yeah, just make it 10. Let's see what happens. I mean, if it was a statistics, we can prove everything. Even when I used to teach statistics, I prove linear regression through like some. Do you guys remember integrals or derivatives? So I used to prove linear regression through derivatives and integrals, but through machine learning, you just do it based on experiment. So we are not sure why 10 is better. Maybe it's not. So let me just make 10. So it's bad, pretty bad. So 10 doesn't seem to be good. So let's make it 2. So with cluster centers, I can find the coordinates of the centroid. So if you run it, so it has 2 centroids. So why in each list centroid, which each list is for a centroid, why I have 7 numbers? Yeah, 7 columns. So previously, when I did this at 3 clusters, she looked at 2 variables, but so like more than 3, we cannot imagine human brains. Very difficult. So since you have 7 variables, each coordinate has 7 numbers. So here with transfer method and also show, I'm just showing the result of my predictions. I just, if you look at the last column tells you about each observation and they belong to which category. So if I run it now, some of them are 0 and 1. So category 0 means one of the category 1. I just have 2 clusters. Maybe you can compare with the actual clusters value that they had here. I think they don't have it here. So let me see. No, there is no name here. Anyway, so you can tell everyone that your silhouette coefficient is pretty high. And with that high coefficient, silhouette coefficient, you can say you have some confidence about labeling your read based on the category that they would belong to. Having said that, if you had actual labels, you had a lot of meat in your plate to discuss, because you could say, okay, you already gave me labels, and when I did clustering, it either they may follow those actual labels. Some of them did have a lot of differences. Maybe you can manually calculate the differences and tell them, although you gave me 3 different weight labels, when I did clustering based on these 7 variables, it seems your label is very bad. Maybe you need to recategorize or rename your weight based on the configurations that you get from your scanning equipment. Having said that, so your next assignment, which I haven't posted yet, just report 5 different silhouette numbers and discuss about your results. I think it's pretty easy. I already gave you solutions, so you just change the number of clusters and talk about reliability of your result based on the silhouette coefficient. Okay, I'll give you a few minutes if you have questions or you want to add some comments, then I go to the next point. And I highly recommend to put comments, so because when you look at them, maybe it looks very obvious, but when you go home, maybe they look weird. You may forget. So if you add some comment, you don't have to watch the video again. So, but anytime, every time I record the video, I just put it on your model. So in case you forget some part, you can just go back and watch it. Yes.
So the average is basically the accuracy. But
no, accuracy, you compare the actual prediction. Sorry, you compare the actual value with the prediction. Silhouette just takes care of distance between observations. Distance between centroid of each cluster to the observations. Huh? Distance. So when it's two-class classification, let's say these are two clusters. So in 2 dimension, we can easily see. So let's say this is your centroid. The centroid of each cluster. You look over distance of them and compare distance of each cluster observation to centroid and compare with all of the distances. Maybe distance here to here. Talking about silhouette coefficient is like above the count for this class, but I highly recommend to Google it and maybe watch some videos. It's a little complex, but again, you just take care of the distance of each observation to its centroid and also the centroid to other observations. So if you have your silhouette is close to 1, it seems the number of centroids is reflecting the actual categories that you have in your observations. So let's say if you have if you actually have two categories, but you make when you did clustering of 10, you have too much clusters. So your silhouette coefficient is very bad. So let's say if you naturally should have 5 clusters, but when you do clustering, you pick 4. Your number of clusters should increase. So if you are close to actual number of clusters, your coefficient, silhouette coefficient is closer to 1. So it's the reason here when we did 10 clusters, it's much more than 2 clusters. So it just said the number was very low. Please do your research, because talking about silhouette coefficient and the methodology behind it is a little bit about the content of this class. So it should be like a computer science class or electrical engineering, but here we look over more experiments, and our focus is on deciphering the result, not methodologies. So you, as a business analyst, you need to decipher the results and make a business decisions out of it. But it's a really good practice to know the methodology. So in case for some topics you want to know, maybe you can dig more into it. There's some good textbooks. Maybe I can share it with you, or you can do your research to see what is the methodology behind like some concept like silhouette coefficients. So for us, when you do, let's say even for prediction. So for us, using neural network, SVM, logistic, decision tree doesn't matter that much. We just look at the final accuracy. But sometimes if you know what is the decision tree or neural network, it kind of helps you to interpret better, but it's not necessary. So I think in your classes, they talk about decision tree, right? What about neural network? No, I mean, in your program. No, yeah. But yeah, neural network actually is not difficult. It's one of the easiest ones. But I mean, for you, look at the final accuracy. Okay, so let me just open your syllabus. So as you see, we're approaching the end of semester, and although in second delivery you should have literature review, also since final project just encompass everything that you already had. So even maybe you can improve your literature review for your final project. So this is almost one of your last semesters. We have higher expectation from you. You need to be more professional. So like in the previous class that you had last semester, last year with me, so I didn't care too much about how you do literature review, but now we have higher expectation. You need to be professional. First of all, even I shouldn't say, you shouldn't copy some write-ups, some paragraphs, whatever, from other resources without citing them. If it's your own word, you don't have to, but if you copy from other people, you should cite. Even, let's say you already have a submission, I had it somewhere. If you don't cite from yourself, it's even cheating. And I know some professors, even they use their own word in different publications, and like some institute cut them. So this is really bad. So even you cannot copy from yourself. So having said that, let's look at an example. Let's say I want to write a prediction project, maybe predicting some hotel reviews. So the hotel reviews start from, let's say, their star. So it could be some hotel could have 0 star, 1, 2, 3, 4, 5, or for Amazon. Yeah. So now let's say I want to write the literature review section. One of the best resources is Google Scholar. Here I just put, or let's say stock market. So I wanted to predict a stock market, and this is a part of my project. And maybe this paper looks good to me, not this one. Let's just pick another one. So let's pick this one. I did the abstract. So somebody did prediction using some machine learning algorithms, AdaBoost, XGBoost, DBDT, whatever, decision tree. So as you see, even in this research, they just tried so many different algorithms, and they just report the best one. But anyway, so let's say I read the paper, and it seems I'm happy with what they did, and also I want to use their work. So I want to simply copy, but let me just look over the results. So people's opinion, which relates to public news, also make a significant difference on prediction process. So I said based on, I make it a space, but I fill it. People's idea is affected by news and have a significantly and would reflect on their reviews. So I need to say who, based on what? So even here I change I rephrase it, but still I use the other people result. So if you don't rephrase it, you should put in a quotation mark. If you rephrase, if you don't rephrase it, put in a quotation mark. Otherwise, rephrase. Okay, so if I want to make my life easier, I copy the topic. It here. Look at the site option of your Google Scholar. Click on it, and there's different methods. You just pick the one that looks better for you. So copy. In your reference, you should have the name. Maybe here, I put based on Yang 2020. Here, I put before quotation mark. Just Google it. There are different ways of professional citing. I just show you the easiest one, but like even if you look at the Google Scholar, so there's MLA, APA, Chicago, Harvard, Vancouver, all of them is fine for me. So you just one that's easier for you. And there is a software that helps you for citing. I don't teach that software to you, but the name of software is Zotero. So this is a free citing software. You can watch like 5 or 10 minutes of video how to use this software, but it helps you to cite it more professional and organize all of those references. So, and you can import from Google Scholar to Zotero directly. So as you see, they have EndNote. So EndNote is another one, but usually EndNote you should pay for that. But Zotero is exactly looks like EndNote, but it's free. So for example, if I click on EndNote, so it downloads a file that I can import it in my Zotero or EndNote. Have you ever worked with the LaTeX or LaTeX? This is a good one. It's not time for learning that, especially if you're close to job market. But the most professional writing platforms, let me just put the name here, so is LaTeX, or some people call it LaTeX. So it looks like Microsoft Word. I mean, sorry, the output is like PDF, but instead of using Microsoft Word, you basically code your text document. Might be super challenging at the beginning, but for professional reporting, it's a good software to learn. If you're close to the job market, if you're on final exam, I don't recommend to learn it for now, but over the summer, if you learn it, you would love to do your write-ups through LaTeX, not even MS Word, but good skills to learn. And it's not difficult. At the beginning, it might be very challenging, and you want to say, what's the point of learning that? But actually, all of the nice looking documents that you see over internet are people have done them by LaTeX, not Microsoft Word. But Microsoft Word is not bad, so don't think I'm saying it's a bad thing. But for nice looking PDF files, you need to do it over LaTeX or LaTeX. for this class, I don't recommend and I don't expect, but at least try to learn Zotero. And when you make a literature, it saves a lot of time. So learning Zotero might take like 10 minutes. You just Google it. And as I said, so here, when I wanted to put the reference here, I just went to Google Scholar back and forth. I copied the name, just came back here, did that. So with Zotero, you just do one click and just it puts the reference on your Word document. So it saves a lot of time. You don't have to, again, like me, you can make it in the old school, come here, copy, come here, just paste. But Zotero, you just go with Google Scholar, just one click, you import it to Zotero. Then in MS Word, just do one click and just put everything there. So highly recommend, again, it's not necessity, but since it doesn't take that much, maybe in like less than 10 minutes, you can learn Zotero. So I recommend to have it on your system. It's free. Anyway, so for your final project, at least have like 10 references. I want you see you guys try to be professional. Having said that, some papers like this one is available here. You can easily download it and see the paper because I'm reading Clark University Wi-Fi, and Clark University already registered on some research journals. If it's registered by Clark University, anytime within the campus area or campus Wi-Fi, I can just download those PDFs easily. Some cases, they are not available. So let me see if I can find some. It's a collect e-resources. It seems I can see it. Full view, I can see that. So I try. Let's see this one. It seems all of them are available. So let's see this one if it's available or not. Yeah, I think. So today I'm liking almost all of the ones that I'm looking for. Let's see if this one is available or not. Yeah, everything is available today. This one. Yeah, I mean, so let me just do something else. Part. Let's say part transplantation. Yeah, I think this one, I just have an abstract. I don't have the whole paper. So if you're, let's say if I don't have this paper, I'll just copy the name and I Google Clark University Interlibrary Loan. So through interlibrary loan, you click submit a request, you log into your account and you make a request. So request article, and you put the article information here, you submit. Library just search for that article and just send it over to you. So you would get an email when that PDF file is available. So again, no worries. I mean, today almost everything that I was looking for was available, but sometimes they may not be available. So you just through interlibrary run, you request from library, and usually they respond in like less than 1 hour. They send you those papers. Okay, so again, keep in mind, and this semester we have a high expectation from you guys. And please do be professional and provide a good final project. So anyway, is there any questions about today's class or final project assignment? Yes?
For PySpark, do, I have changed my topic. Like when I was trying to do it for my original topic, I realized that the data set was not very good. So last minute, I changed my data set and I did it on a new topic. So do I have to resubmit phase 1?
No. So in each phase, or I mean, for each delivery, you can just change your topic. That's fine. Because it's, I mean, first time you're learning PySpark, and maybe, I mean, or maybe the data set is different from what you expected. So that's totally fine. Even for your final project, you can have totally different. You can have totally different data set, but for final project, you also should have literature review, descriptive statistics, everything that you have for other topics is better to have for final project. So if you're lucky and you're happy with your current data set, maybe you save a lot of time for the final report. Because final report is conclusive. You should have all of the previous things that you submitted before. So next session, so the plan is we make more complex notebooks, like doing cross-validations, looking for text mining, and also we do Twitter analysis. So you learn how to connect to Twitter, and you learn how to download the tweet data and doing some text mining using the data that you downloaded. So before reaching that point, you need to have some experiment over text mining. We had something similar in the previous class, business intelligence class. So we did through 9. This time we did through PySpark coding. Again, I need to ask a question. Have you ever done text mining through Python before? Okay. Again, the big picture is very similar to 9. Even you can make pipelines, much more similar to 9, but we use PySpark coding, and basically the point is we convert the textual document to its equivalent numerics. If you convert to equivalent numerics, then you can easily apply any machine learning algorithm and do your predictions, or sometimes you need to do clustering. So maybe if you look at my previous sessions about on text mining over 9, it helps a lot, but it's not necessary. Yeah, so we had 2 sessions of text mining. One was lexicon-based sentiment analysis, which was, it didn't have any machine learning. We just look at some dictionaries of positive and negative sentiments. After that, we had a sentiment classification, which we convert textual document to its equivalent numerics. Then we use some machine learning algorithm to predict the sentiment. So that workflow could be helpful. And also, yeah, so also I would teach you how to connect to AWS. So similar to local instance, you can make a cloud-based instance over Amazon website and have Hadoop and Spark available. And also you can make a Jupyter notebook on their website and just run PySpark codes over their platform. So that's another topics that you have by the end of semester. Also, we had some recorded sessions, and I might share with you guys, so in case to see what other people did in your major. Yeah, I just see any questions even from Zoom. So, okay, so I haven't posted your assignment yet, but I mean, the last project I explained, so you can just, maybe you can keep working on this workflow, on this notebook and make your assignment ready. So don't just do simple clustering, also talk about the silhouette coefficient and try to interpret your results. Okay, so let's just stop for today, then we go over attendance.